Alright guys, so this video is going to be on sampling distribution. I'm not going to do too many examples, just the ones that most people were confused about. So, let's start with the first one. It says, for the population with a standard deviation of 10, so this is example number 1, population with a standard deviation of 10, how large is the sample necessary to find, or to have a standard error that is, and then we'll go into different numbers. Okay, so for this we want to know what population or what sample size do we need to have to get certain standard errors. Okay, so we're also finding standard errors. So the first one we want is a standard error less than or equal to 5. So standard error less than or equal to 5. Alright, so what n do we need to get this standard error less than or equal to 5? First, I always write out my formula. So standard error is equal to standard deviation over the square root of n. Now I'm plugging all my knowns. So we know the standard error needs to be that, right? It needs to be less than or equal to, or you notice how the greater than is on that side, so I'm going to make that. It has to be greater than or equal to this guy here. So we know our standard deviation is 10, and we don't know our n. That's the thing we're trying to figure out. Alright, so now we want to solve for n, but in order to do that we have to multiply both sides by n first, and that cancels out. Now we have 5 square root of n is greater than or equal to 10. Divide both sides by 5. That cancels out. Now we have square root of n is greater than or equal to 2. We have the square root. Right, we gotta get rid of that, so n is greater than or equal to 4. 2 squared is 4. And that's our answer. Let's try another one. Alright, now we have to have a standard error less than or equal to 2. Okay? So first thing I do is I write out my formula. Standard error is equal to standard deviation over the square root of n. Plug in your knowns. This time I'm going to write this on the left side first. So 10 over square root of n is less than or equal to 2. Same thing, right? You have to make sure that the 2 or the terms are on the right side of the greater than or equal to symbol. For example, I can write this another way and it will be the exact same thing. See? This symbol here, this variable, is on the small side of the whatever this thing's called, the greater than equal than sign, and the 2 is on the large side. The 2 is on the large side. This is on the small side. Here, the 2 is on the large side. That's really important when you guys are doing these greater than or equal to, or greater than less than things. Okay, so now I'm going to solve for n, but the first thing I need to do is I need to isolate the 10, because the 10 over n is kind of in the way. So let's multiply both sides by n. Okay, that cancels out, so now we have 10. We're going to keep this the same way. Okay, but now the 2 is attached to the n, so I want to get rid of that. So let's divide both sides by 2. Those cancel out. Now I have 5. Keeping this the same thing. These just keep going down. Okay, I'm not changing anything. But now this n is attached to the square root. So opposite of square root is square. And 25 less than or equal to, I'm keeping everything the same, n. Or, and rewrite this, n is greater than or equal to 25. Okay? So what does that mean? That means I have to have a sample size bigger than or equal to 25 in order to have a standard error that is less than 2. You don't believe me? So let's try n equals 24. Okay, we're going to do n equals 24, which is smaller than 25. Alright? Let's try that. And let's see if our standard error is going to be less than or equal to 2. Let's try it. So standard error is equal to that over that, right? It's equal to 10 over oh, excuse me. Alright, so 10 over square root of 24. Let me get my calculator. And the square root of 24 is, let's see, 4.9. Let's say 4.9. Alright, 10 over that, 2.04. Interesting. So we wanted a standard error that's less than or equal to 2. But if we had just one thing lower than 25, we have 2.04. So this is not less than or equal to 2. 2.04 is greater than 2, right? But let's try 25. Let's try 26. Just to show you why we're doing this stuff here. N equals 26. Okay? Which is greater than 25. Our formula again is standard deviation over square root of n, which is equal to 10 over square root of 26. Is equals to 10 over square root of 26, which is 5.09. Let's call it 5.10. Whatever. 10 over that, we get 1.96. 1.96 is less than 2. So, when we chose a value that fit into what we found, a number greater than or equal to 25, we found that the standard error is less than 2. Right? Standard error is less than 2. Okay? So that's why we do that stuff. Let's try one more. Let's try one more example. This is example C. This time we need a standard error that is less than or equal to 1. Okay, our standard deviation is still 10, and we need to know what n do we need. Okay, the formula is, okay, plug in our knowns, so we know that this has to be 1. And the 1 is on the greater than side, so we're going to keep that the way. It's still on the greater than side. And we're going to plug in that, and we don't know n, because that's the thing we're solving for. Solve both sides by n, or multiply both sides by n. These guys cancel out. So now we have n, which is, we don't have to write the 1, because it's already assumed that this is a 1n, right? So now we have this. But we have a square root, so we have to get rid of that. We're going to square both sides. Square both sides. So now we have n is greater than or equal to 100. So we have to have an n that's greater than 100 in order to get a standard error that is less than or equal to 1. Got it? And I showed you that if we plugged in 100, we'll get 1. If we plugged in 101, we'll probably get something a little smaller. If I plugged in 99, I might get 1.01 or something. And that won't fit into our original specification. Okay. So now we're going to do finding z-scores. Okay? Finding z-scores using sampling distribution. So our n given is n equals 25. The sample mean, which is big M like that, is 84. Okay. Now we're given what would the we need to find the z-score. Okay, and we're given the first one is A. If it was obtained from a population with a mu of 80 and the standard deviation of 10. Well, that's the first thing we need to do. First thing we need to do is find the standard error. Standard error formula is this guy here. Plug in your knowns. 10 over square root of 25 plus 10 over 5 equals 2. Our standard error equals 2. Now we can plug this into the z formula. Z equals m minus mu over standard error. Right? Actually, I'm going to pause on that. Yep, my formula is correct. So it's sample mean minus mu over the standard error. And if you think about it, this is the same as x minus mu, except we're using the sample mean. So this is kind of like the score, what we're working with, minus what's the average over what we expect the error will be. Okay? Anyways, let's get to work. So we know the big M is 84. We know the mu is 80. And we just found the standard error is 2. Okay? So that's 4 over 2 and equals to 2. Equals to z. That's our answer. Okay? Let's try another one. Let's try if it was obtained. I'm going to do it on a new page here. If it was obtained from a population with a mu of 80 and standard deviation of 20. Okay? Let's say I saw this problem and I'm like, oh, what should I do first? I'm going to try to find the z-score. Z equals, and our givens were 84 and its n is equal to 25. This is all the variables that we were given. So we know that z equals m minus mu over standard error. Okay, so I'm going to plug in all my knowns. 84 minus 80 over, oh no, I don't know what this guy is. So you have to solve for that first. Okay? So in order to do that, I'm going to go, oh, I can't solve this because I don't know what that guy is. So I'm going to do this. 20 over square root of 25 equals 20 over 5 equals 4. Right? Just make sure here. Sometimes I get these things wrong. Okay, yes. So now I know it. 4. So 4 over 4 equals 1. Z equals 1. Got it? Piece of cake. That's pretty much the basics, so you guys should be able to figure out the rest based on this. So, thanks for watching. I hope it helps.